All right, so let's go ahead and get started. My name is Robert Ronan. I'm a principal product manager on the developer adoption team. First off, thanks for attending today's webcast, and thank you to Marcy Samuelson for putting this together. We have an amazing presentation today from the TriggerMesh team. We have Mr. Gary Mike, Vice President of Sales and Business Development at TriggerMesh, and Chris Bombauer, Solutions Engineer. If you have any questions during today's session, please put your question in the Q&A area, and we'll be sure to answer those in our live Q&A after the presentation. This webcast is also being recorded, and we'll make it available shortly after the webcast. Again, thanks for joining. And before I turn it over to the TriggerMesh team, I'm going to go through, take a few minutes of your time and discuss Oracle's container engine for Kubernetes and talk a little bit about cloud native services on OCI. This is Oracle's safe harbor statement. Basically, it's stating that don't make any purchasing decisions based on future plans or unreleased products. Basically, do your due diligence before making any sort of purchases. So let's talk about Oracle Kubernetes as a service. OKE is a fully managed, scalable, and highly available service that you can use to deploy your containerized applications to the cloud. It's all based on upstream versions supported by the Cloud Native Computing Foundation, CNCF. And this basically means that there's no vendor lock-in, there's no need to re-architect your application when moving from an on-premises Kubernetes deployment to the cloud. As you can see here, when you contrast the right side to the left side, customer managed versus Oracle service, you can see what is actually part of the managed service offering. So scaling, high availability, platform backup and recovery, upgrades, software installation, and so forth. These are all part of the managed service. So the benefit here is that as a customer, you have a faster time to deploy, better reliability, lower risk, and you can spend more of your time building your applications and innovating versus maintaining the infrastructure that Kubernetes is essentially running on. So all of Oracle's cloud native services are built on top of OCI, and OCI is Oracle Cloud Infrastructure. These services can be categorized into application development and operations, observability, and messaging. Oracle provides these services, cloud native services, that combined with OKE will give you a robust and scalable cloud native services environment. Fully compatible with Kafka, logging compatible with FluentD, native monitoring, notifications, API gateway, allowing infrastructure to run as code, and lets you run your own Terraform stack in the cloud through our Resource Manager UI. We also support functions and several other services that will assist you with your most demanding workloads. And since OCI and OKE are based on open standard services, you can bring your own open source software along with your Oracle Cloud Native services. This slide contains a few examples of what Oracle's been doing in the open standard services ecosystem, supporting the Linux community in general. Oracle is a platinum member of the Cloud Native Computing Foundation and a member of the Open Container Initiative Linux Foundation project. We're very serious about open standard services and supporting the Linux community in general. Oracle is the only major cloud provider to deliver and support a unified cloud native solution across managed cloud services and on-premise software, supporting a seamless bidirectional portable environment or portability of cloud native applications built anywhere. OCI provides bare metal, virtual machines, containerized compute, GPUs for high performance intensive workloads such as AI and ML, and a variety of cloud storage options like block, object, file storage, and archive. OCI offers an array of services for developers to build modern applications, and OKE uses OCI as the main underpinning of the platform for all of its services. We don't restrict any users to any single programming language. And you can use any programming language or framework of your choice, Java, JavaScript, Node, Python, Ruby, and you can bring any of your own DevOps tools to OCI as well. Let's take a look at some of the components that make up OKE. So when you look under the covers at OKE and OCIR, OKE runs highly available Kubernetes clusters. It's developer friendly, enterprise ready, offered as a managed service, and keeps pace and compatibility with the CNCF ecosystem. OCIR, or Oracle Cloud Infrastructure Registry, is a container registry service that enables users to easily store and share container images. This allows users to pull images with the Docker CLI and pull images directly into their OKE environments. This is probably one of my favorite slides in the entire presentation on the cloud native aspect of it. And I'll share this with you and let you know why. So we talked briefly about open source initiatives, OKE and OCIR, but let's talk about value. And when you break down the costing model at a high level, the area on the left designates the functions that Oracle manages for our customers as a managed service. Oracle manages etcd, master nodes. The upgrades are supported within the Container Engine dashboard, and it's very easy to upgrade the OKE master nodes and the node pool servers. You decide as a consumer or end user when you want to do these upgrades. So what do you manage as a user? You manage the cluster, worker nodes in your own OCI account and tenancy, shown here on the right. So what does this end up costing, or what is the value that we bring? So the OCI registry is offered at no cost in terms of the service. OKE, or the engine for Kubernetes, is a no-cost service as well. And what you're essentially paying for is the consumption of the compute, the storage, and the networking data plane that underpins and supports these services. So the value is tremendous, and these services are offered at no cost. We briefly touched upon OKE and OCIR. Let's talk about a little bit more about the service broker. The service broker is an implementation of the Open Service Broker API. You can use the service broker to provision and bind to OCI services. Presently, the service broker can provision and bind to ATP, Autonomous Transaction Processing, ADW, Autonomous Data Warehouse, Streaming Service, and Object Storage Service. The key benefit of the storage broker is to reduce the complexity in app deployment. With the service broker, it's easy to get your own OKE microservice talking to Oracle Cloud Services. So this is essentially the connection point allows you to bind these services together. As we know with containers, there's two types of deployments. There's persistent and non-persistent, or stateful and stateless. So how do you make sure data is persistent with OKE? As you know, containers are well suited for stateless apps, but use cases may vary. Your app may require the use of external data stores for persistence, and with OKE and persistent storage, this is completely a supportable use case. OKE provides services and capabilities for both stateless and stateless apps. Your apps can easily integrate into existing databases, ATP, ADW, and you have access to all stateful-based storage services. A couple of the recent updates and highlights with OKE. We're supporting Kubernetes 1.19.7, Cloud Shell, Container Storage Interface, or CSI support for monitoring Kubernetes with the API server using OCI Audit Trail, autoscalers, HPA, VPA, and cluster autoscalers, and OKE API, unscheduled pods and metrics. And with that, I'd like to turn it over to both Gary and Chris from the TriggerMesh team.
Thank you very much, Robert. Let me share my screen here. Everybody should see that okay. Thanks, Robert. So TriggerMesh Oracle partnership at a glance. Folks, I just have a few slides, I promise, and we'll get to it. Before I get started on this slide, on the bottom is a QR code. If you want to learn more about TriggerMesh and what we offer and how we get better your integration process and speed to delivery, take a picture of that or scan that QR code. So the TriggerMesh Oracle partnership at glance. We've been certified on OKE. We've tested out. Robert and his team actually helped us on that, and the components run flawlessly on it. We actually have an event source because we're an integration engine that works with Oracle DB in the cloud, autonomous database, or on premise. The ability to collect information from that Oracle database, send cloud functions across, and lastly, send metrics. We have a customer that we're going to show you, actually demonstrate you at after these couple of slides, that shows collecting OCI metrics and sending them off to different targets. We send them to Datadog, LogZ, things like that. But not only we integrate with Oracle, we're a multi-cloud partner. We have partnerships with AWS, Red Hat, so forth. So the final on this is we're the go-to partner for integration in the Oracle space, if it's on SaaS or if it's on-prem. So what is TriggerMesh's vision? Enterprises need to build an event-driven application that integrates services from multiple cloud providers and on-premise applications, excuse me. We create by integrating workflows between cloud services and on-premises applications. We're going to dig a little deeper in that in 1 second. How we do this and why we're better than anybody else out there is we automate it. We automate it with declarative APIs, taking advantage of the Kubernetes platform with a declarative API, using and deploying with CI/CD pipeline. It takes your integrations and automates those in real time. Lastly, we accelerate. Because we integrate so quickly, automate the entire process, it takes your digital transformation, your DevOps teams, and we accelerate them exponentially because of the technology built on Kubernetes. So TriggerMesh at a high level, 50,000 foot view. Sources are events that are produced by your cloud event. A source could be Oracle database. It could be Kafka. It could be a IBM MQ, GitHub, GitLab, Bitbucket, any one of those. The broker in the middle there, we take these sources, this information in real time, and turn it into a cloud event. The reason why we turn it into a cloud event is because then we could transform it, which is very important because not every target, which I'll talk about in a second, can just receive information as it comes across. It can also be split. We have a thing called a splitter. It enables you then to take the event, this cloud event, and split it and go to one target, multiple targets, or send it back to the source with different information on it. And then targets. Targets are those things that consume this information. This can be due to workloads in Kubernetes, any cloud services as functions. An example is Salesforce, Twilio, SendGrid, Kubernetes, OpenShift, or any one of the places that can be a target. But what makes us an advantage of what we do is we're based on Kubernetes. What we do is TriggerMesh fully distributed containerized Kubernetes application. It means you can run anywhere, any place. TriggerMesh's API is extendable by Kubernetes API set, so there's nothing to learn. It's built on top of that. Leveraging Knative incorporates Kubernetes objects like secrets, config maps, definition integrations. Packaging and deploying these can be done by Helm charts. I talked about that in the very beginning, is deploy integration as code. So lastly, an event-driven, powered by Knative, integration, inherent, loosely coupled, allowing unlimited extensibility. And on the bottom there, you guys can see it. Declarative APIs, no expensive consultants. You could do this in-house, or you could bring your own integrations, catalog of bridges, and of course, we have a nice GUI. So lastly, what you're going to see here from Chris is metrics to Datadog. We had a customer in the East Coast. They're a banking regulatory institution. Their problem was they had multiple clouds, AWS, Oracle Cloud, OCI, Azure, and they needed to get all the metrics into one place and send those off to Datadog in real time. The solution was to run a bridge connecting OCI metrics, autonomous database, to Datadog. I talked about this in my middle slide there on the bottom, the graphic here. You have a source, the Oracle Cloud Data API. We grab that. It goes into a broker. We turn it into a cloud event. And then the orchestration translation takes the information that we get from Oracle and translate it into a digestible piece of information, cloud event, that now can be sent over to Datadog via their APIs. With that, I'd like to show you the demo here. Chris?
When you first log into TriggerMesh, regardless of whether you're using our SaaS product or the on-prem solution, you'll see our bridge catalog. From here, you can see any number of our templates. We even have a template for going from the Oracle Cloud, retrieving their metrics and putting them into Datadog. But for today's example of showing multi-cloud experience, I want to show how easy it is using our wizard. So when you enter into the bridge editor, you'll see the basic flow of the source, which produces our events, the broker that actually acts as the collector, the trigger that will inspect the cloud event payload to determine whether or not it should fire a particular target, and then of course the target itself that does something with the event. When you go into the source, you'll see we have a collection of sources to choose from. Some of these are proprietary, some of these are community contributions or open source. Some are also fairly generic, like the webhook, which exposes a REST endpoint that you can hit with your own service to submit a JSON-style payload to be processed by TriggerMesh. For now, we're going to use the OCI metrics. From here, I'm going to select my API key, give it a name, Now, for the metrics that I'm going to be collecting from both the Oracle Cloud and also from AWS, it will be the CPU utilization metrics for my Kubernetes clusters. I have one running within OKE and another one running on AWS as an elastic Kubernetes service. And because my OKE cluster sits in a compartment, I'm going to add that one in there. Now, for the metric namespace in the query, I'm going to pull that information from the Oracle Cloud Metrics Explorer. You can see I already have a query pre-selected, but one of the things that I wanted to highlight that I really like about the Metrics Explorer is the fact that for the metrics that are displayed, it pretty much denotes all of the services that I'm actively using within the Oracle Cloud. And of course, you can fine-tune which metric and all of the knobs here. And what you end up getting as a result is the metric query that you can use as part of your Oracle Cloud SDK or in platforms like TriggerMesh within our metric source. AWS CloudWatch, on the other hand, requires a little bit more digging in order to retrieve the similar information. And last but not least, I'm going to bump up my polling frequency to be about 1 minute. So that's the source. Now, as far as the target, we also expose quite a few offerings, some of which are proprietary, some are open source. We have a Confluent target that allows you to send cloud events from TriggerMesh into your Kafka cluster, or you can even use that to go into the Oracle Stream service. We have our Datadog target, which we'll get to later, and then an HTTP target that we can stream our events to if we have another SaaS-based HTTP server that we want to send our events to. We even have an Oracle Cloud function handler. But for everything else, including the targets where if you're bringing your own using our own APIs, you would actually go through this service to add it in. Now, here I'm going to use the Sockeye service, which that and the event displayer is what we use in-house to inspect the events as they come in and allow us to debug our own bridges. So we'll save that, and then I'm going to submit my bridge. So once the bridge is submitted, I can go to the dashboard to get the total number of the bridges that I have running, as well as all of the related services. I can go into sources, where I can see that my source is up and running, and I can also go into services, where I can see all of my running targets and services. And if I click on Sockeye, then I can leave this running, and I'll have my Oracle Cloud metrics come in once a minute, and then we'll see it get picked up from there. So while that's going, I'm going to go back into my bridge, and I'm going to add in the next layer, which is going to be the translation layer. Now, with the raw Oracle Cloud metric payload, what I'll get back is an array of elements where each element will have the resource name or ID, and then an array of data points in there. So I need to unroll both of those arrays in order to create a event payload that Datadog can understand as a target. And for the Datadog target, we actually use the Submit Metrics API endpoint. So we would accept a similar payload as if you were to use this endpoint directly using something like Perl, where we would be setting a series, the host name, the metric name, some data points, and the type of metric. And for that, we actually have like two different translators that we can use. We do have a CRD that we've defined that allows you to do simple substitution of key value pairs, and it's all done through a declarative API. We also have a more complex approach using Infra.js. Now, Infra.js will allow us to take a cloud event payload as it comes in, do our own translation, and emit the response as a new payload. And for that, I already have a function that's pre-written, which I'm going to copy and paste in. And here you can see that I'm defining it as the IO TriggerMesh Datadog metric submit type. And my data payload consists of a series, which is, in this case, an array of the OCI dev prefix for my metric name. And then this is where I'm unrolling each of the elements within the metric, collecting the host name. And if I don't have it, then I'll use the resource ID. And here I'm unrolling the data points by translating a traditional date timestamp into a Unix timestamp. And then, of course, converting the value into a string. And to see that, if I go over to Sockeye, you can actually see what I'm talking about, where here's our first element consisting of my cluster name, or sorry, my node name, and my aggregated data point. And then we have that for at least the other two nodes. So I'm going to call this DD translator for Datadog translator. I'm going to save it. And then I'm going to submit it. Now, once this target comes up, then for each additional cloud event that comes in from the Oracle metrics, that'll get converted into Datadog. So now the last piece that we would need to do is we need to add in our hook for Datadog. And to do that, I'll plug in Datadog, select my key, call it Datadog Target. Now, one of the things that you'll note is that a trigger was created with the target. By default, the visual editor will automatically create the pair for you. And also by default, the trigger will fire the target for any event that comes in. In the case of the Datadog target, though, we actually wanted to only fire on a particular event type. So I'm going to specify type, my cloud event type. And if I scroll down, I should have my translated Datadog type. Paste that, save it, and submit it. So now we're going from the Oracle Cloud into Datadog, at least the metrics, that is. Now, one last piece that I'm going to add in, and this one I'm actually going to showcase our YAML editor, is the AWS component. And for that, I'm going to copy. And here you can actually see this is one of our other custom objects that we call trigger flow, and or at least the bridge and the component itself is trigger flow, where we have different components which are Knative or TriggerMesh specific objects. So like the broker itself is a Knative object. The OCI metric source is actually more of a TriggerMesh based object. And when I paste that in, now we have CloudWatch, where we have polling interval of 5 minutes, our normal AWS credentials. And here you'll see that we actually define 3 different metric queries as opposed to the one that we have for the Oracle Cloud metrics. In this case, the reason for doing this is because we need to specify the instance ID as an individual element within the dimension for our metric. Another thing to note is that the finest grain that we can pull for the CPU utilization is actually on a 5-minute interval. So we have that there. You can see Sockeye is my normal Knative service. And then you can see my triggers as well as my translation target. So I'm going to submit my bridge. And while that's going, if I were to go take a look at my metrics dashboard, or at least the metric summary, and if I hit reload, you'll note that we go from 18 elements into 19, and my CPU utilization is down here at the bottom. So if I were to click into that, you'll note that I have my 3 hosts. So I can open it up in the Metrics Explorer. I can actually create a graph per host, and you can see that I do have like at least 2 elements in corresponding to each of my nodes. But one of the things that I want to do is I want to take my aggregated CPU utilization, and I want to send this into another dashboard. So I'm going to send that to my multi-cloud demo dashboard. I'm going to export that out. And now you can see I have at least 1 dashboard component, which I want to add in here. And I'll do the same thing once we get data from AWS. So let me close that. I'm going to switch back over to my summary view. And this is where we'll just wait for the AWS event to come through. Okay, let's reload. Okay, and we have our AWS CPU utilization metric in place. We take a look at Sockeye and scroll down to our past most of our Oracle events. You'll see we do have, in this case, it looks like 2 of the 3 nodes reporting in. So if we go over to our summary page And if we were to click on the AWS CPU utilization, we can see our 3 hosts have been tagged. So now if we open up the Metrics Explorer, you'll note that we don't have anything in our graph, but we do have a lone data point. And that's mainly because of the fact that it took 5 minutes for our initial data point to come in. And if I do the breakdown, you'll note that it's only present in 2 of the 3, which is to be expected. So cool. Now, only thing left to do for us is to export this into our little multi-cloud demo dashboard. And if I were to go here, oh, let's try this again. Oh, there it is. Now I can edit the widget. Do that, save changes. And now I have the aggregated view from my dashboard looking at both the CPU utilization from my Oracle Kubernetes cluster and my AWS Kubernetes cluster. Sweet. So that's how easy it is to be able to rig up a simple bridge. We mainly just went through adding in the Oracle source, added in AWS for their metrics, created a simple translator to pump all that data into Datadog. Now, if we wanted to route data back into either one of those clusters, we can. We have the sources for that and also the targets. So yeah, that's pretty much the demo.
Thank you, Chris.
Thanks, Chris. That was awesome. Really enjoyed that. So we've got some questions that came in through the Q&A. Let's just go through these one by one. We'll take the first ones that came in. So the question is, TriggerMesh looks similar to Dell Boomi and MuleSoft. What are the major differences?
Very good question. The major differences is that we're built on an open platform. We're built on Kubernetes. We take all the information we receive from the different platforms, if it's Kafka, Salesforce, whatever, we transform those into a cloud event. The cloud events now are able to be manipulated by you. You don't have to have expensive resources to deploy TriggerMesh. You could deploy it on-prem. You could deploy it on any cloud provider that out there that has Kubernetes, which is all of them today. And of course, we have a SaaS offering, and we could do a dedicated SaaS offering also. So really the difference is time to market, the ability to do my own deployments, and the CI/CD pipeline of my declarative APIs is a total game changer in this industry now, as we see at TriggerMesh.
Okay, got a couple others. In the demo, you showed different sources and targets. What others are available for use?
You know,
Yep.
Do you want to handle this one, Chris? Or you want me to handle
it? You can handle this one.
Okay. So we have, it comes in from sources from all the AWS products, from those, all the Oracle products that are out there. And then we also have stuff that's called Bring Your Own. We can also come from OpenShift. We have, we're on the Red Hat marketplace, just like we're on Oracle's marketplace. Oracle DB, vSphere, IBM, MQ, things like that. Definitely from Kafka. Confluent is the Kafka one is a big winner in our space. A lot of people look for how to take the Kafka messages and turn them into cloud events to use in other areas, maybe for CI/CD pipelines, for managing code bases, things like that.
Is the TriggerMesh UI the only way to create and deploy bridges?
Absolutely not. Definitely a CLI. And we're also, as we talked about, is we're doing integration as code, which means you're going to be able to write a few lines of code and actually deploy an entire bridge. It's very exciting technology, and love to show it to you.
A couple more here, and if anybody wants to put, for those that haven't, there's a Q&A button at the bottom, not the chat. Put your questions into the Q&A. How do you get started with TriggerMesh?
It's really simple. We actually have a SaaS offering that is free to start out for 30 days, and we support it. Just go to triggermesh.com, start a trial, and away you go. It's pretty straightforward. It's in the chat right now. I see that Greg put it in there for you. Fully documented, obviously. He's got the docs there, that's why I mentioned it. But definitely start out on the SaaS. Reach out to us. We have a Q&A window in our platform. Enables you to ask questions right to the engineers, not to a salesperson. And you talk right to Sebastian, this Chief Product Officer, and all the engineers, including Chris, are available to help you with it.
Can you explain more about event transformation or how it works in TriggerMesh?
I'm going to leave that one to Chris.
So the event translation happens pretty much, we can do one of three ways. First way, we, being entirely based on Kubernetes and Knative, we support the full Kubernetes aspect of defining custom resources. So one of the things that makes us unique is that we provide a custom resource to allow for simple transformation of your events, whether it's going to be changing things like the cloud event type to some of the payload offerings based off of the incoming payload, or to handle the case of like just a one-to-one type mapping, adding attributes, removing attributes. Two other approaches. Second one, we do have a target which I highlighted during the demo called Infra.js. This allows you to provide some simple JavaScript in order to handle some of that more complex translation while being able to use the UI. Of course, being entirely based on Kubernetes, we can embed this one as part of the bridge, as part of something that you would have as part of your GitOps process, and then being able to use something like kubectl or kubectl to apply it into your cluster with Kubernetes running. Third approach, which I don't think we touched quite on with the first question, is that we also support the option of bringing your own targets as well. These would be like a normal Knative style source and target. In this case, you can write it in whatever language you want. It'll come in as a normal HTTP request with a JSON payload and the cloud event spec-based headers. You can do your translation that way. So if it's more complex, like having to call into a different microservice in order to enhance the data, do what I had done earlier, like being able to unroll arrays, so on and so forth, you can actually use that to push things out too. So those are the three ways that we can manipulate cloud events within the TriggerMesh platform.
Great, thanks, Chris. That was our last question.
Excellent. Robert, I put something on the screen there, the last slide. I think it's probably the most important one because possibly you'll win a $25 gift card. Go to the QR code that was on the screen earlier, or go to TriggerMesh webinars and download a white paper. You might win a $25 gift card. We have Kubernetes OKE information and free trials for the, of course, Oracle Cloud. I'll leave it to you, Robert.
Great, thank you. And with that, I think we can conclude if there's no more questions. Just give everybody another 30 seconds here.
Awesome.
And just a reminder, this session was recorded. The recording will be made available in the next few days. And then again, if you have any questions, you can always reach out to sales@triggermesh.com, or you can reach out to one of their engineers through their website. And with that, I will conclude this webinar, and thank you to everybody.